All right. So lines, usually we see it in this form, right? Mx plus b. M represents, as you know, the slope of the line, right? And b represents the y-intercept of the line. Okay. So when you are sketching, usually if you have it in mx plus b form, right? Let's say we have an example here, 2x plus 1. So what you do, you go and find the y-intercept, which is 1. So you place that, right? Then you look at the slope. So slope is rise over run, right? So in this case 2 is like 2 over 1 in this case, so rise 2, run 1, right? So you start from this y-intercept, you run 1 and rise 2. Run 1, rise 2, and put those points and sketch the graph. Sometimes the equation may not be in mx plus b form, that is fine, or the y-intercept may not be an integer. Maybe it is like, you know, a fraction or something. Then you cannot use this method, but what you can do, one method, you can find x-intercept and y-intercept of the line, place those points and sketch the graph, right? Another way, just try to find any other point on the graph that has integer coordinates, integer x and y coordinates, and then place those in the grid and sketch the graph. All right. So that is lines. Also, let's remember actually vertical and horizontal lines, right? Let's say you have y equals -5, okay? So you find -5, that's a horizontal line. How about vertical lines? They have equation as, let's say, x equals 3 or x equals -10. So let's say x equals 8 is going to look like this, right? So those are vertical and horizontal lines. So let's look at parabola or quadratic functions. So if you so this is the standard form, ax squared plus bx plus c, okay? Let's say if you have 2x squared plus 4x minus 7, it is in standard form, okay? To be able to sketch a parabola, so your equation must be in vertex form, okay? Now, I don't know, probably you remember how to convert standard form to vertex form. So we have a special process called complete the square, okay? So let's do this example. So then it will, you know, it will come back to you if you forgot. This is what we do. We look at the leading coefficient. We factor it from the first two terms, not from the constant, okay? We factor it from the first two terms. So 2x squared plus factor 2 from 4x gives you 2x. Okay, then we are what you do. Yeah, we are doing complete the square process. So we have 2x squared plus 4x minus 7. We're going to put it in the vertex form. Okay, convert standard form to vertex form. So we factored the leading coefficient from the first two terms. Okay, now next step, that was step 1. So you look at the number in front of x, you divide it by 2, then square it. Okay, so we have 2 here, we are going to divide it by 2, gives you 1. We square it, 1 squared is still 1. So then we add and subtract 1 in that bracket, okay? So we add 1 and subtract 1. Actually, you know, this means you are not changing anything in this bracket because plus 1 minus 1 is 0, right? It's just helping us to put it in the vertex form. Next step. Keep the positive number that you added inside of the bracket and take the negative number outside of the bracket. As you do that, multiply it with the number in front of the bracket. So I'm keeping positive 1 inside. I'm going to take negative 1 outside, multiplied by 2 gives you negative 2. So 2x squared plus 2x plus 1, negative 1 times 2 gives you negative 2 minus 7. Okay. Next, factor the perfect square trinomial. Now we have x squared plus 2x plus 1. Factor it. It gives you x plus 1 square. Okay. And collect the numbers that you see outside. Right. So that is complete the square process. After you put it in the vertex form, right, what you do, this represents h, this represents the k value. And let's remember, vertex is h and k, right? So first you place the vertex in the grid. So in this case, vertex is negative 1, negative 9, negative 1, negative 9. So don't forget, it is, if it is plus 1, actually that gives you negative 1 for the x-coordinate of the vertex. Okay, so you place that. So negative 1 and negative 9. Okay, then you check if the leading coefficient is positive. If the leading coefficient is positive, then the parabola opens up. If the leading coefficient is negative, parabola opens down. Right. Another thing that you need to look at is the number. So it is 2. So there is a stretch, right, by a factor of 2. Then means this is what you do, right? You go 1 right. So the first you remember, of course, the step pattern. Originally, if the a is 1, it is 1, 3, 5, actually all the odd numbers. Okay. Now looking at the a value, in this case it is 2, you multiply that step pattern with that a value. So in this case now we have steps 2, 6, 10 and goes, right, 40. Okay, so this is what it means, right? So you go 1 right, 2 up, 1 right, 6 up, 1 right, 10 up, and you do the same thing on the left side. 1 left, 2 up, 1 left, 6 up, 1 left, 10 units up, and this is how you do your parabola. Are we okay with quadratic functions? So any problem with completing the square? Should we do one more example or? You're good? Okay. So next time when I see you virtually, you can still ask. Alright. Now let's remember then exponential functions. Exponential functions are going to look like this, right? Y equals a to the power of x. Okay. So that variable not in the base anymore, like x square, right? Variable is the base for x square, but in this case variable is in the exponent. So those are called exponential functions. If the base is greater than 1, then you have an exponential growth. Okay, so let's say if it is 2, the function is going to increase to the right. Okay, like this. It's a growth, exponential growth. So let's remember those functions, exponential functions, they go infinity, right, for both sides, but there is an asymptote. If there is no vertical shift, the horizontal asymptote is located at y equals 0. So in this case, this is the horizontal asymptote here, y equals 0. But let's say if you had 2 to the power of x minus 5, right, then the horizontal asymptote then is going to be at y equals negative 5. So there's a vertical shift 5 units down then, right? That's how it would be. Or if you have 2 to the power of x plus 3, then your horizontal asymptote is located at y equals 3. There's a vertical shift. So this horizontal asymptote is affected by vertical shift. Okay, it can only move up or down, right? If you have an exponential function, but this time the base is less than 1. By the way, it cannot be a negative number, right? For exponential functions, the base must be always a positive value. But let's say that positive value is between 0 and 1. Okay, so in this case 1 over 2. Alright, then they are called exponential decay. Okay, oh sorry. So as you see, exponential decays, see, they are falling to right. So they are always decreasing, right? So this is decreasing. Of course, if there is a reflection on something, that's another story. But if there is no reflection, if you have 1 over 2 to the power of x, 1 over 5 to the power of x, 0.1 to the power of x, right? Those functions are exponential decay, and they are falling to right, they are increasing. Same thing, so there is a horizontal asymptote at y equals 0 if there is no vertical shift. Again, this asymptote may move up or down based on the vertical shift. Okay, another function to remember is square root function. Y equals root x. Okay, so let's do a little table here. So as you see, under that square root you cannot have a negative number. Okay, the minimum value that you can have is 0. So if you take 0, then the y is square root of 0 is 0. If x is 1, square root of 1 is 1, so y is 1. If x is 4, y is 2. If x is 9, y is 3, right? Those are the simple values. So if you put those, that's how they look. Now let's look at the next page. Trigonometric functions. Okay, so y equals sine x, y equals cos x. For now, I just want you to know simple ones. Okay, so you don't need to know for now the phase shift or change in period. Okay, I just want you to remember the vertical stretch or compress or vertical shift. That's it for now. Okay, because later on we are going to look at trigonometric functions in more details. Right? So let's remember sine function. Okay, then x is 0, sine of 0 is 0. Then x is 90 degree, sine 90 is 1. Sine 90 is 1. Sine 180 is 0. Sine 270 is negative 1, and that is 1. And sine 360 is 0. How would you remember that? So probably you're going to remember it from grade 11. So there's a unit circle that we usually use for the angles that are let's say 90, 180, 360, 270. So those are the angles that are on x or y axis, right? So 0 degrees here, 90 degrees here, to 180, 270, and 360. So those angles are located on x or y axis. Okay, and if let's say we have xy coordinates on a unit circle, okay, so x coordinates represents the cos theta and y coordinates represents sine theta. Okay, all right. So then if you have a unit circle, let me draw it one more time here, let's make it clean. Okay, if this is a unit circle, x coordinate of this point is going to be 1, y coordinate is 0, and here x coordinate 0, y coordinate 1. Here x coordinate negative 1, y coordinate 0, and here x coordinate 0, y coordinate negative 1. Okay, so if you are looking for, let's say, cosine 90 degree. So you come to the 90 degree. First coordinate is cos. Second coordinate is sine. Okay? If you are looking for cosine 270, right? You come here. So x coordinate is 0. So cosine 270 means is 0. And sine 270 is negative 1. Are we okay with this? Yeah.
Why did we assign cosine theta to x and sine to y?
So there's a proof for that in grade 11, but maybe later on, if you want more details, we can go over it. But if there's a unit circle, so the first and if you have so many points on that circle, right? And you take any point on that circle, x coordinates of that point represent cos theta. Okay, and y coordinate represent the sine theta. Okay, on a unit circle. Okay, so actually we can prove it here. Do we have enough time? What time is it? Okay, so let's say you have a point here, okay? So that, let's say the coordinates of that point is x and y, okay? So means that this is x, right? And that is y, correct? Okay, so you have theta here. Maybe I should have made even bigger here. So that is, we said that is theta, that is x, and that is y. And we are talking about unit circle. So if it's a unit circle, that hypotenuse of that triangle is 1 unit, okay, because that is the radius of that circle. That is why it's called unit circle, because the radius is 1 unit. Okay, if the radius is 1 unit in the circle, so whenever you need to draw a triangle, right triangle, using the given point, the hypotenuse is going to be 1 unit. Okay, so this is 1 unit, this side is x much, and this side is y much. Okay, if you write cos theta here, okay, what is cos? Adjacent over hypotenuse. What is adjacent? X. What is hypotenuse? 1. X over 1. So that gives you x. See? Now this point, coordinates of that point is x and y. So now we prove that cos theta is x. Alright? And if you do sine theta is opposite over hypotenuse. What is opposite? Y. What is hypotenuse? 1. So opposite over hypotenuse, y over 1, which is y. Now we prove that sine theta is the y coordinate. Is that okay? Alright. So yeah, so now you kind of need to remember just a bit that, okay, sine starts from a 0. Okay, for now again we are not looking at the phase shift, we are not looking at a change in period. So then what you have? A 0, 0, 0 is you start from this origin, okay? Then after 90 degree you have a maximum, after 90 degree you have another 0, after 90 degree you have a minimum, you go another 90 degree and you have a 0 again. So those are the significant points that we use for sine theta. For cosine, very similar. The only thing is your start point is maximum, okay? So for cosine, you start from a maximum. After 90 degree, you go to the 0, 90 degree minimum, 90 degree 0, 90 degree maximum, okay? Because let's remember, those significant points happen every quarter period, and one period is 360 degree divided by 4, you get 90 degree. So every 90 degree, if there is no change in period, every 90 degree you get a significant point. Okay, so those significant points are zeros, max and mins. Alright, so let's remember another function which is called rational function, or it can also be called reciprocal function. Okay, so that is 1 over x. In the graph for it, if there is no shift or anything like that, are going to look like this. Okay, so you have basically two asymptotes, one vertical asymptote, one horizontal asymptote. Okay, so vertical asymptote, again, if there is no change in no horizontal or vertical shift, it is located at x equals 0. Okay, and the horizontal asymptote is located at y equals 0. Then you have two branches. Okay, like this. So if you make a table of values, let's take a couple of values here. Okay, let's say then x is 1, or let's start from 2. Let's say x is 2. Then 1 over x is 1 over 2. So that is 1 point. 2 and 1 over 2. Okay? Let's say x is 1. 1 over 1, 1. Another point. Okay? Let's say x is 0.5. 1 over 0.5 gives you 2. Okay? So 2 and half, 1 and 1, half and 2. Right? Can you put 0? No. Right? 1 over 0 is undefined. That is the reason you have an asymptote there. Okay? So x cannot be 0 because there's an asymptote there. Okay, how about negative 0.5? Right? 1 over negative 0.5 is negative 2. Or negative 1. 1 over negative 1 is negative 1. Negative 2 gives you negative 0.5. So you can also place those points there. Okay? And you approach the asymptotes, you don't pass the asymptotes. Actually, later on in the second unit, you will kind of see, is this unit or next unit? Even it may be this unit. You will see that we can pass through the horizontal asymptote, but we cannot pass through the vertical asymptotes. Okay, for other functions.